zeros of polynomial functions. So we had a remainder theorem in the last section. We now have a factor theorem, a rational zeros theorem, a fundamental theorem of algebra, conjugate zeros theorem. So starting out, make sure I'm on the right page, use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. So factor theorem, I'm going to show you both. If I don't specify how you have to show it, then you can choose either method, but I'm going to show you like both ways to do these. So number 10, we've got x cubed plus 6x squared minus 2x minus 7, and we've got x plus 1. So the remainder theorem basically, the factor theorem, we used the remainder theorem the other day. Factor theorem basically says that x minus k, or in this case x plus k, is a factor if and only if f of k is equal to 0. So that means that if I take f of this number, but remember this would be, I need to like set this equal to 0 and move it over. So x equals -1. So if I put -1 in here and I put it anywhere I see an x in this equation, if it comes out to be 0, then it is a factor. If it doesn't, it's not a factor. So I would just have -1 cubed plus 6 times -1 squared minus 2 times -1 minus 7. So that's going to be -3 plus 6 plus 2 minus 7 so we get, what was that, 3, 5, -2. Oh, wait. Anybody else catch that? It's supposed to be a -1, not a -3.
This guy did.
I was sitting here and I was like, I don't think that's right, but I don't know.
I didn't want to correct you.
Oh, no, go ahead. I make mistakes all the time. I by no means get things, especially basic math. It's fine. All right. So that ends up being 0, so this is a factor. I tell people all the time, I'm like, basic math is not my strong suit anymore. Once they handed me a calculator, all went down the drain. All right, so we can also check it by synthetic division, which is what we did yesterday. So by putting in -1 in the box, and then 1, 6, -2, -7. So bring down the 1, times -1 is -1, plus 6 is 5, times -1 is -5, it's -7, times -1 is +7, minus 7 is 0. So we basically just checked that it is a factor. All right, 18, same instructions. We have 2x cubed plus x plus 2 and x plus 1 again. So that means when I plug it into the factor theorem, I'm going to have f of -1. So then I have 2 times negative 1 cubed plus negative 1 plus 2. All right, let's see if I can do this right this time. Negative 2 minus 1 plus 2. So that's equal to negative 1. And so it is not a factor. Now, obviously, the good thing about checking it in the last problem, if I had left it as negative 3 instead of negative 1, I would have realized when I checked it that something was wrong, and then I just would have had to figure out where I went wrong. So then checking this one, got negative 1 in the box. Now notice we have a term that's missing, x squared is missing, so I'm going to have to make sure I put a 0 in for that. So 2, 0, 1, 2. Bring down the 2, times negative 1 is negative 2, plus 0 is negative 2, times negative 1 is 2, plus 1 is 3, times negative 1 is negative 3, and we got negative 1. So again, just checked that it's not a factor. All right, so the next problem, say factor f of x into linear factors given that k is a 0. So I think this is where you were trying to go with these problems yesterday, where you're like, I need to keep going. That's basically this step now is where we're going to keep going. So they tell us that k is in fact a 0. Okay, so they've already given it to us, so we'll copy it down exactly when we run synthetic, and then we'll talk about how we keep going after that. So 22 f of x is equal to 2x cubed minus 3x squared minus 5x plus 6, and k is equal to 1. So we're told that it is a 0, but we still kind of need to verify it, but also at the same time, that's how we're going to get down to, basically we're trying to get a whole bunch of like things that are factors multiplied times each other. So I put 1 in the box because it's already given to us as k equals 1, so we just put it down exactly. No terms are missing, so I just copy them down as they are. So 2, negative 3, negative 5, and 6. Then run synthetic, so bring down the 2, times 1 is 2, minus 3 is negative 1, times 1 is negative 1, minus 5 is negative 6, times 1 is negative 6, so that's going to be 0. So basically, that just verified that it is a 0. Or a factor, however you want to do it. So our factor, though, we have to set this, so we basically have x is equal to 1. That means our factor is x minus 1, okay, because that would be equal to 0, which is where we get our factor from. So that's the part that we're going to take with us. So every time I do one, I like to take it down to the next step so that I know that I have it. So this is the factor that I'm going to be using. So this was an x cubed term. It's now going to be x squared. So this is going to be 2x squared minus x minus 6. Now, we haven't gone over yet how you could have possibly found other potential zeros. But we do know when we have something that looks like this, how to just factor it. Okay. So I need factors of, using the ARG method, negative 12 that give me negative 1 when I add them together. Anyone know what those factors might be?
4 and 3. Or 3 and negative 4.
Yep. negative 4 and 3, because when we add those together, we get negative 1. So I'm going to have 2x squared minus 4x plus 3x minus 1. So I had to rewrite the middle term. I'm going to factor by grouping now. So take out the biggest thing I can. So I'm taking out a 2x. And that leaves me with x minus 2. I don't know why I wrote minus 1. That's supposed to be minus 6. So then over here, I can take out a 3. And that leaves me with x minus 2. We always want these to match, so I did it right. So I take this up that's outside, the 2x plus 3, multiply it by x minus 2, and that would be those factors. Then to put it all together, I need to bring this factor down. So I would also multiply this by x minus 1 and just set it equal to f of x, because that's what it was to begin with. And so now I have factored what I started with by them simply just telling me what one of my zeros or factors was. Let's see, 26. Now, some of these problems in this section have like eyes and stuff in them. I'm not going to like give you those ones. I'm gonna prioritize the stuff that's real and not imaginary. I'm not going to say when we get farther on in this chapter we won't have some of that, but we don't need to do it with what we're doing right now. So, f of x is equal to 8x cubed plus 50x squared plus 47x minus 15. And the 0 is k equals negative 5. So I'm going to run my synthetic with negative 5 in the box. No terms are missing, so copy down exactly. 8, 50, 47, and negative 15. Bring down 8. 8 times negative 5 is negative 40. Plus 50 is 10. Times negative 5 is negative 50. Plus 47 would be negative 3. Times negative 5 would be 15. Minus 15 is 0. So I verified that it is in fact a 0. So that was x equals negative 5. I really don't like that the book says k, but you know, whatever, it's fine. Because ultimately it's x equals negative 5. Move this over, so our factor is going to be x plus 5. And so that's the factor I want to make sure I don't forget to bring down. So now, this was x cubed. We're now going to be x squared. So I've got 8x squared plus 10x minus 3. So arch method. I need factors of negative 24 that give me a positive 10.
6 and 4.
Well, so the only way that that's going to work is for one of them to be positive and one to be negative. So that one's not going to work.
Yeah.
12 and 2, so positive 12 and negative 2. Because multiplied gives me negative 24, added gives me positive 10. It doesn't matter which one you put with which thing up here, so I'm just going to do 8x squared plus 12x minus 2x minus 3. Factor by grouping. So in the first set, I can take out a 4x, and that's going to leave me with 2x plus 3 over here, the only thing I can take out is a -1. And I'm left with then 2x plus 3. Stuff inside matches. So then I've got 4x minus 1 times 2x plus 3 would be those factors. And then I need to bring this other one down that I already had. That's probably the biggest thing people forget is bringing that one down. So then we just need to multiply by x plus 5. And we would be done. All right, the next thing is, all right, there's a lot to this. For each polynomial function, list all possible rational zeros, find all rational zeros, and then factor into linear factors. So this is kind of putting everything together, but also a little bit of new. So when we have a problem like 40, as f of x is equal to x cubed plus 5x squared plus 2x minus 8. So in the previous problems, they've told us that something was a zero or a factor or whatever, and we were able to run synthetic off of that. But now we're doing it if they don't tell us what they are. And so we have to find all possible ones. And so we have a rational zeros theorem, which says if p over q is a rational number and if p over q is a zero of f, a polynomial function with integer coefficients, then p is a factor of the constant term and q is a factor of the leading coefficient. So basically, in terms we can actually understand, this term goes on top, whatever number's in front of the highest powered term goes on the bottom, and we're going to list off all the factors of it. And it's always going to be plus or minus, because with the multiplying and dividing, we could have one that's positive, one that's negative, and things like that. So we list all possible ones, so it's going to be plus or minus 8 over plus or minus 1. I wish these ones had a, well, okay, we'll do one in a minute that has a number in front so you can see what happens. But this will be the easier ones to start with. And so basically what we would do is we would, on top, list off all the possible factor combinations of basically what can multiply together to give me 8. But we write them in numerical order. Okay, so I know that 1 is a factor. I know that 2 is a factor, so plus or minus 2. 3 is not. 4 is, so plus or minus 4. And then I know that 5, 6, and 7 aren't, but then 8 is. So if I pick 2 of those numbers and multiply them together, they're going to give me this number on top. That's what I'm trying to do, is list off every one that I can. On the bottom, 1 is only 1. So a lot of times when it's one that's over 1, I won't write it this way, because then what we have to do after that is we have to rewrite them, and you're going to be like, this is super obnoxious because they're basically already written like that. But when we get to ones that have other stuff on the bottom, like a number that's not 1, we have to write them all out. If there's ever a repeat, we don't write that, which is going to happen when we have stuff on the bottom. So I'll pick one of those in a little bit so you can see what that looks like. But anyways, we're going to start basic. So now what you need to do is you need to get out your calculators, because the next step is that we need to graph this. Now, if you learned this elsewhere, Tristan, have you seen this before? Okay. Because when Ethan came to me last year and I was teaching this, he refused to use the calculator for this. And when we do another problem in a little bit, you'll see why. I don't know why he wouldn't use the calculator. I think he will now. But But I guess when he was at Menchville, they wouldn't let him use a calculator for this, and so you had to do all of these by hand, which is miserable. So I'm going to show you how to do it on the calculator. Then we just verify it by hand because sometimes it's hard to tell, and then we go from there. So I'm going to turn this on. All right, so on your calculator, when we go to y equals up here, if you have something already there, just clear it. And then what we're going to do is we're going to put in this function exactly to the calculator. So x raised to the 3 plus 5x squared plus 2x minus 8. Oops, not that. So it should look like that when you're done. Make sure you can read it, but also... Then you're going to hit zoom, and then 6 is standard, and so that's just graphing it basically from -10 to 10, and so on and so forth. Are y'all lost, or are you good?
I don't know how to get the third power.
Oh, sorry. The little caret button over here, it's like it looks like this. If you hit that, and then just the number 3, it'll do it. I never know how much people have already been taught to use their calculator, because in Algebra 2, when I'm going over stuff, they're like, can you slow down? I don't know what I'm doing. And I'm like, oh right, you've never used this calculator before. So I never know if people have seen it before.
We use decimals.
Oh, yeah, I don't like that. So zoom standard is going to be from -10 to 10 in both directions. So that's what we will always, well, I say always. Anything like this, that's where we're always going to start. If we need to go elsewhere with it, we will. So that graphed that function. So what I'm doing is I'm looking at this graph, and I'm going to try to see where these zeros might be. Okay? And so it looks like I could have one at -1, -2, -3, like at -4 maybe. So I'm going to write down that one as an option. -1, -2 looks like it might be a 1. And then over here, maybe +1 will be 1. Now, it's a cubic function, okay? So whatever your highest powered term is, that's how many zeros you should have. But what we're going to learn later on, not in this section, is that sometimes you have, well, it might be in this section, I don't know. You might have imaginary or complex zeros, which you won't see. And then you also might have a zero that's technically repeated. And so we call that a multiplicity, but anyways, we'll do that. So we're going to take these 3 numbers and we're going to run synthetic. But I really only need to run synthetic once, because after that it should get me down to something that I can factor. Were y'all able to get it graphed?
I don't know what the equation is, because I was trying to get it.
Oh. This.
Oh. How do you go back?
We'll just clear it. Let's restart the instruction.
It's like, we're just going to clear.
Was +5x. Squared. 5x squared plus 2x.
How do we show the graph?
Huh?
How do we show the graph?
Oh, hit zoom, which is the middle button on the very top. Or, well, I don't know if your calculator looks like mine.
And then hit it again.
Hit that button and then hit the number 6, which should be zoom standard. You can either arrow or you can just hit the number. It doesn't matter.
Did you use them last year? Oh yeah, because we have what's it called?
We need to do it on paper.
What was the app y'all used? Math.
Something.
Is it like MATLAB?
It's
I
I
don't know,
hated
it's
it.
like an online thing, but
It was
we
the
weren't
worst.
allowed to use calculators.
The guy just talked and his voice was so annoying.
Yeah.
Okay, so basically, like, I had a teacher who didn't really let us use a calculator either. Like, he would show us how to do it, but then we weren't allowed to use it on a test, so it was kind of, like, pointless.
Yeah.
And so, like, when I started teaching, I was kind of, like, of that philosophy. I was like, well, you don't need a calculator. Like, I'll show you how to use it so you know, but then as, like, the longer Kenny worked at the shipyard, he was like, you know, everything that I have to do, like, I have a calculator for. He was like, so all these teachers that are like, you can't have a calculator, he was like, it's pretty pointless because when you get out in the real world, you always have one. I mean, you literally have a calculator in your pocket all time, like at all times.
Yeah.
She said we weren't allowed to use it because we weren't allowed to have one like in the ACT or whatever.
But you can.
Maybe it was backwards. Maybe she said we could use it.
Did you use it?
I don't know. But I also, because I found out that on the SATs and stuff like that, because when I took it, you could only have a basic calculator. Like the little, like, scientific at best. Like, it couldn't be a graphing calculator, but now they let you use, like, the big fancy one. So I try to, like, teach you as much as possible how to use your calculator usually, because that way when you get to an SAT or something, it can benefit you rather than potentially, like, hurt you or just not help you. So, anyways.
I might study the calculator ways.
Because, I mean, your calculator is pretty smart, so it can do a lot for you that, you know. But in the spring, come back. But in the spring, the SAT is going online anyways.
Really?
Completely online.
That's actually good.
Never be pen and paper again.
Wait,
I would have hated that, but
would we take it before spring?
the SAT,
Yeah.
you have to sign up for that on your own and pay for it and do whatever. I would recommend you take it in the spring, probably.
I want to take it online. Right?
Well, starting in January, from what I've heard, it is only
Oh,
online.
in January? Okay.
Like
So anyone that
online-
you sign up for.
Online, can't they like change the questions basically? How many you get right? Like it'll get harder.
I think it's going to be a set thing for everyone. It'll basically be taken like in a computer lab instead of, I don't know. I feel like it's going to be way easier to cheat.
I thought that's what he said.
I don't know.
Oh,
You'd have.
here I
I would
come.
say ask him, not me, because I only know about it because somebody was like, "Oh yeah, it's going online in January." I thought it wasn't going online till March, but I don't know.
I'm about to get the best.
You gonna get a 1600?
Yeah.
I did better on the ACT.
Online, I get perfect score.
All right, so now we're gonna take this and we're gonna pick one of these numbers and we're gonna do synthetic division. I'm gonna let y'all pick which one of the three do you want to do.
For where?
Oh,
Just tell me a number.
-2.
-2. All right, we're running synthetic on -2.
Because I like -2.
Negative 2 to 2 go different.
All right, so I've got 1, 5, 2, -8. Okay, so we're running synthetic just like we normally would now that we found these potential zeros, ones that we think might work. Bring down the 1 times -2 is -2. Plus 5 is 3 times -2 is -6. Plus 2 is -4 times -2 is +8 minus 8 is 0. So the good news is it came out as 0, so we know that that is a 0. So x minus 2, or wait, sorry, x equals -2. So then my factor is going to be x plus 2. Okay, so I need to keep that handy because I'm going to need that when I get to the end. Because basically now that we have these, we're back to what we just did in these problems up here. We just have to do the initial step of finding the zeros. So you have a couple options now. I now have an x squared term, x, and then a constant term. You could run synthetic again, or you can just factor. It doesn't matter. I would say factor because it looks way easier because it's x squared plus 3x minus 4. And what would that factor into? Yep. x plus 4, x minus 1. And so then I can just bring this other one down, this x plus 2, and you factored it.
So why did we have to graph it?
Because we needed to see which zeros could potentially work. So I looked at the graph and I saw where it was crossing the x-axis to try to see which ones might be an option. Now, this one was all whole numbers, so I would say this was a relatively easy problem. Now, if you've never seen it before, you're probably like, this isn't easy. It will be when you see the next one that's got numbers that are not whole numbers.
We did this last year.
You'll see why. Yeah, I think my mom was like not sure if she was gonna get to it, and I was like, please get to it.
Yeah.
Because it's
But
not.
we didn't use a calculator in the beginning part.
How do you find that?
She may just have you run them all. But when we get to the next one, because I think at the end she told me, and I was like, I use a calculator for that, and I explained why, because I usually like the Algebra 2 book doesn't really get that like complicated with them or that many, but the pre-cal book does. And I was like, if any of yours come to pre-cal with me or like college algebra, I was like, they're gonna need to know the
'Cause I don't
graphing
remember it being
part.
super hard.
And she was like, oh, okay. So I think she was, well, she's not teaching it this year. She's teaching something else. But
How do you do it without a calculator? How do you find that?
you would check positive 1, you'd check negative 1, you check positive 2, you check negative 2, you check positive 4, you check negative 4, you check positive 8, you check negative 8. So you would have run 8 sets of synthetic.
Unless you
Now,
find one in the beginning.
Once you find, as soon as you find one that works, you could have just factored. But let's say you were like, I'm going to try all the positive ones, like, or well, maybe not a good example because obviously positive 1 worked, but you say, I'm going to try all of the, the positive ones, and let's say there had only been negative ones that had worked, you would have just checked 4 before you ever got to one that worked. Which is fine, except for there was one that I gave pre-cal that had 32 possible.
Yeah. That's
Yeah. I couldn't figure out why Ethan was like, because last year he had it and he was like running, I mean, I'm telling you, his paper had all these synthetics. I was like, why didn't you just graph it?
you know, I
No, I mean, like I had taught it. He knew how to do it. He just was like, well, this is the way I learned it. So it's just the way I do it. Like he factors differently too, like than I do. And I'm just like, I don't understand how you factor, but if it works for you, whatever works. All right, 44. We'll probably have to stop after 44 and we'll pick it up on Monday. But I'm going to go ahead and give you a few problems so that you have something that you can be like working on and not have it all at once. F of x equals 15x cubed plus 61x squared plus 2x minus 8. So it's always constant term on top, leading coefficient on the bottom, and then we're going to be factoring it. So we're going to have plus or minus 8 over plus or minus 15. So I'm going to list out all my factors of 8. So we already did that one up there. So it's 1. And I'm not going to say the plus or minus, but I'm putting a plus or minus in front of every single one. So 1, 2, 4, and 8. So on the last one, the bottom number was just a 1. So I normally wouldn't even have written it as a fraction, but because I knew what we were going into, that's why I did it that way. So now I need the factors of 15. So that's going to be 1, again, all plus or minus, 3, 5, and 15. So then I'm going to write a list of them all, okay, of what all the ones could be before I graph it, because I want to know what I'm working with. So each of these numbers is going to be put over top of each of these numbers down here. So initially I'm going to have 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So I'm just going to write them as the whole numbers. So 1, 2, 4, and 8. Then I'm going to have each of these numbers on the top over 3. If at any point I get to something that can reduce to one I've already written, I don't write it again. Okay, I don't know if this one's going to have any that happens for, but sometimes it does. So I'm going to have 1/3, 2/3, 4/3, and 8/3. Then I'm going to have each of these numbers on top over 5. So 1/5, 2/5, 4/5, and 8/5. And then I'm going to have each of these on top over 15. So 1/15, 2/15, 4/15, and 8/15. Now, I know that at most, because this is a cubic function, 3 of these will work.
Let's do 1, 2, and 4.
So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 32 options. So this is the one that has 32 options. I have 32 possible synthetics I could run. But I don't think you want to do that. So that's why we graph it. Okay, so on your calculator, you would graph this. So you'll just have to go back to y equals, clear that, and then type in what is written here. So 15x cubed plus 61x squared plus 2x minus 8.
Twice. Twice.
And then once you type it in, we'll hit zoom, standard, which is number 6.
Oh,
Is
yeah.
that a baby?
Not in my school. Gotta catch some hands. Yeah. I didn't punch him.
All right, so just while you're finishing up graphing this, so what you might notice about this problem is that there looks like a lot happening right here in the middle. And because I have so many fractions in here, that could literally be anything, okay? I'm going to go over here and I'm going to look and see if any of these whole numbers look like they might work. So it's -1, -2, -3. Looks like -4 is a possible one. Maybe. Over here, this looks like I'm about, I don't know, halfway between or so. I'm going to say like maybe 1/3. Or -1/3. Over here, it might be -1/5 or +1/15. I don't really know. I'm just looking at things that look like they might work. It looks like, I mean, I don't know. It's hard to tell exactly.
So go right on the line.
So that would be.
Go
Are you
right
figuring out tricks over there that I haven't taught you yet?
Go right on the line.
There's a function on your calculator that will tell you what they are if that's
Yeah.
what you're trying to do.
Yeah.
No, it's like, is it the thing that like moves around?
Well, that's one of them, but there's actually a trick that will tell you what they all are. But I haven't shown you that yet.
It's a trick. You can't always let all the tricks out the bag.
Now, I'm going to show it to you in just a second, but I don't know what they all could be, but I'm going to list off ones that it looks like might work because, you know, never know. I would say if you get a whole number and you can't tell about all these fractions because there's so many, I really don't know which one it would be without zooming way in, and I might be able to see it. I'm going to check synthetic on that one, so just leave your graph off to the side if you have it, and I'll show you the trick after we do the synthetic. So I'm going to try -4 because that one probably looks the most consistent. So 15, 61, 2, and -8. And I'm going to really hope and pray that this one works, because if not, we have to do fractions in synthetic. Which sometimes we have to do, and that's okay, but I like whole numbers better. So bring down the 15 times -4 is -60. Plus 61 is 1. Times -4 is -4. Plus 2 is -2. Times -4 is +8. Oh, good. -8 is 0. Hallelujah. So that means x equals -4, or the factor would be x plus 4. So again, I'm going to hold on to that one. So a lot of times what I'll do is I like to go back and circle or put a little check mark by the one that I know works. Now, at this point, I know that this is something I could just factor, okay, because I'm down to 15x squared plus x minus 2, and then I can just factor that, and I don't need to worry about running any more synthetic. Now, if we had a problem that was like to the 5th power, I would have to keep going because I can't just factor that off the top of my head. But fortunately with this one, I should be able to factor this. So factors of -30, that add up to give me +1.
Six and 5.
Yep, and
Be, 5, no, -6, no, 5, -5 and 6.
yep, -5 and 6. So I've got 15x squared minus 5x plus 6x minus 2. Factor by grouping, take out a 5x, leaves me with 3x minus 1. Take out a 2, leaves me with 3x minus 1. So that means my factors would be 5x plus 2, 3x minus 1, and then don't forget to bring down this other one. So that would be times x plus 4. And that would be it factored. Now, if the problem wanted me to say which other numbers were zeros as well, okay, that was part of what it asked for. So because of the route that we went to do this, I just need to write what the other zeros are. And so that just means setting each of these things in parentheses equal to 0 and solving for x. So 5x plus 2 equals 0, and 3x minus 1 equals 0. We had already said that -4 was 1, so I just need to figure out the other ones. So this would be 5x equals -2, so x equals -2/5. So that was not what I had guessed. So -2/5 is another 0. And then 3x equals 1. So x equals 1/3. So again, not what I had guessed. So if I had just done it by synthetic, I would have been doing synthetic for a while. So -2/5, 1/3, and what was it, +4, -4 were all my zeros. So I'm going to give you problems up through this point. They're not going to be due on Monday, but I would recommend you at least, like, maybe look at them a little bit. What? I don't want you to be lost. All right, let's see. 13, 15, 23, 25, and then from what we just did, 39, where it just has a 1 in front, and then 45. And then we have a little bit more that we'll do with it on Monday. And then we'll do some review and stuff on Tuesday for a test on Wednesday.